All right, we'll give it just another minute while everybody trickles in.
Sounds good.
All right, thanks everyone. I'm Walter, is the field CTO and analyst at GigaOm. GigaOm, we talk about and we focus on engineering-led research, helping enterprises move at the speed of market. And today I'm joined with Chad Millay. Chad, do you want to say hi and introduce yourself?
Hi, yeah, I'm Chad Mealy with StarTree. I do work on marketing and developer relations here.
Thanks,
Excited to
Chad.
be here and walk you guys through what I think turned out to be an excellent report by GigaOm and share some case studies with you around real-time analytics.
Thanks, Chad. So it's been kind of fun. I'm an old data guy, and so this has been a great time to talk about some of the really exciting changes that we see in the market here at GigaOm. Anytime we put together a report, we usually put together what we see as a lens of vendors in the field, and I'll talk a little bit more about that. But today we're going to be talking about real-time analytic databases, and we're going to be moving from data warehouses to real-time analytics and why we need those and why we see this kind of as a category and a really emerging category in and of itself. So Chad, let's get started and go ahead and jump to the next slide, please. So at GigaOm, when we create kind of a lens for the field, we start to look at what are all these databases doing? And we started putting together kind of a survey of, as you've got data coming in and you need to do real-time analytics on it, are you doing kind of like what we've always done? And that's kind of an ODS, an operational data store. It's just literally a copy of your transactional data. But the problem with that is, and the problem that it's always had, is that database is just literally a copy of transactional data, and it wasn't really designed for complex queries, time series forecasting, period over period production, or using kind of the columnar store or data store that we've all kind of become used to. So data warehouses didn't really work here. Data lakehouses were a little bit better because I could now start doing some streaming data, but that didn't work. The other thing that we've got on here is one of the newer database types, and that's vector databases. But there are problems with vector databases as well. Vector databases work really, really well for things like Perplexity, where I'm doing kind of a query, not based on semantics, but based on vectors and how machine learning stores data into a database. And then I'm also looking at streaming data platforms, kind of Spark and some of the other things and Flink and how we're pulling data off. And can I do queries on that? Most of the time, it's really good for just simple queries, but don't really give me good deep analytics. Same way with data observability platforms. I can get data coming in, but can I get analytics? Can I do complex queries over time? And then time series databases. This is kind of one that was near and dear to my heart because over the years I've done a lot of Cassandra. Those are really good, but I can either do time series, but if I want to do analytics, I have to make a copy of the Cassandra, run it in a different ring, and do different things. So it's not always great. So this is where we start to see some of the overlap and some of the things that we see in the market around real-time analytics databases. Other things kind of sort of do it, but didn't get us all the way there. So Chad, you want to jump on to the next slide? So the difference that we were seeing in the market was traditional data platforms were purpose-built for the specific workloads that they were trying to do. In traditional data warehouses, we had data latency. That data came in, we did ETL, ELT, transformed it, put it into the data warehouse, and then you got your analytics the next day. That's not always great when you're trying to do analytics and on the data as it's arriving. Are you trying to do things? Are you trying to make decisions on it? That was great for when I've got my executives and they're looking at long-term horizon decision making. Was yesterday good enough? No, I need to be able to make decisions on my data right now and be able to do good things with it. The other problem was query latency. We talked about in ODS, those operational data stores. For me to try to do it, roll it up and do analytical queries on that because the structure wasn't right, it was really difficult to do it fast enough and be able to get good queries because those queries could run for minutes at a time. And again, now I've missed that window to be able to make good decisions on my data. And then finally, there's a high cost. As I'm trying to do something that wasn't purpose built for it, often I would have large amounts of data, other data sets that it just made it really inefficient for scaling out and scaling up under those real-time analytics. So Chad, do you want to jump on to the next slide?
Yeah, one comment there. I really like the way you laid that out and talked about it. One of the things I've seen, and tell me if you have as well, is one misconception around real-time analytics is it's really just about that middle box, right? It's how fast can I get the data back? And often people ignore the data latency part, right? So to truly be a real-time analytical database, it's not just that the queries are returning fast, but the data isn't stale, right? It's one thing to batch load yesterday's data and then optimize and tune it for a fast query, but you're still answering a question on yesterday's data, right? And it's a hard engineering thing to do, optimized for both the data latency and the query latency. I think
well,
the other
let me kind of build on that because that's a great point. Because when we talk about query latency, as we were looking at the last slide, some of those other tools where I'm just pulling in streaming data, I only have access to what's in that data stream. I don't have access to legacy data that's really going to give me, oh, I'm looking at a large set of data. Can I get my information back? And is it good? Because now I'm not only looking at what's going on right now, but I could be looking at trends. I could be looking at other things. I could be looking at your buying history. What I'm looking at is only what's there. So again, that query latency, how do we get it a broader set of data, not just what's in the stream and happening immediately, but giving what we were looking for was that long-term data set.
That's right. The other thing on the high cost is interesting too, because this comes up a lot where I think people say, hey, I've got a data warehouse and real time it's, if I want my queries to come back faster, if I want to load the data faster, I just throw more hardware at it, right? But there's a cost to it. And I have to balance, the requirement from the end user and what are pretty steep costs to go solve that. And I think what's unique now about this new classification of analytic databases is when they're purpose built for real time, it's not about throwing more hardware at the problem, right? I think if you're trying to solve this problem using technology that wasn't designed to do it, yeah, right, throwing hardware at it and incurring the cost works. But what you'll see too, I think both in the report and through some of the case studies, a lot of companies, when they switch to an analytic database that's optimized for real time, you actually see costs go down because of just the efficiencies around the original design center.
Right. So when you were thinking about this, so go back a second. Let's keep kind of building on that cost because this is a really key thing for CTOs, CFOs as they're looking at this. To get that data, I need multiple systems all trying to talk to each other and doing multiple things. So you're right about throwing more hardware at it. As that data scales up, now I'm looking at data storage, I'm looking at data cost, I'm looking at multiple systems that I'm having to pay more. And as I try to scale that up, then those costs go up almost exponentially. And your revenue is going to go up in a linear fashion. So as you throw more hardware at it, those costs are going to go up in a hockey stick fashion, and you're rapidly going to eat through any profits you were making based on those decisions. So this again is a really key thing that you were saying, Chad. This is where then that high cost, when you're looking at purpose built, this really then starts to fit then that both financial business need and then the business need of, hey, I'm going to make X amount of profit off this. My costs have to be below that to be profitable.
And I like the dimension you brought to it. I was just referring to throwing more compute at it, but as you mentioned too, there's hardware ways of accelerating things. You can store it in memory and more high cost storage. That obviously is going to lead to higher costs. But I think one of the things that we're seeing in this emerging space is you can actually get really low data latency and query latency on very cost effective storage like S3, like increasingly an Iceberg. And it's a bit of a paradox, right? You typically think of those as they're cheap but slow. But if done correctly, if designed correctly with the right indexing and pruning, you can actually get very high real-time performance, but still leverage the low-cost nature of those storage mechanisms.
Yeah. So now let's talk about why are real-time analytics databases a little bit different. So we've got the first point I'm going to make on the slide, and I hate to read out points, but I think this is going to be good if we kind of walk through these, is data ingest versatility. Can I get to my data from where it's coming in? Because I'm looking at that data pipeline, and the closer I am to that user where I can make the decision, the faster, the better off this is going to be. So I need to really be able to have that versatility that says, I'm going to where the data is. Often, right, without that purpose built, I'm having to go to where the data lives, which may be in a data lake, maybe in a data warehouse, maybe downstream. I need to be as upstream as possible to really make this good. Then the next piece we want to talk about is schema and layout flexibility. When I'm looking at a data schema, I want to be able to be versatile and say, what data is coming at me? I may have different schema sets. How's that data structured? Is it JSON? Is it something else? What's coming in, and can I manage that quickly and do something? Then indexing techniques. This is really now a new key that we need to think about, because as my applications change, I need to be able to figure out how I want to index that data. And that's going to also manage in terms of how fast I can query my data. And I'm also looking, because as I'm looking at an analytic system, I'm not just looking at the data coming in. I may be looking at some legacy data or other data that I'm using to be able to go and make fast queries. That's also going to determine the speed in which I can bring data back, right? A good index makes all the difference in the world in terms of query flexibility. And then optimization for retrieval. How am I getting that data back, and any of the pre-processing? Because not only do I need that streaming data, but then I need some processed legacy data, again, with the indexing techniques, it kind of all works together. That query engine optimization is another point, because when I'm looking at my query engine, I want to be able to do different things with it in different query types, and I need to bring that back. Am I looking at, kind of a cube set of data? Am I looking at, just other analytics queries to be able to kind of bring that back? And so the more flexibility I have, not just a one size fits all or one size fits most or size just fits one use case. I want to have multiple use cases that I can do in there that's going to give me flexibility in terms of, hey, I can throw pretty much multiple business use cases at it, do different things with my query engine, and be able to handle that. The next one's scalability. Can I just stick stuff in memory and that's all I get? Or can I scale this out to terabytes, petabytes, something reasonable in terms of how much data do I need to be able to make the right decision? Again, the more data you can throw at a system, the better decision it's going to make, always, but within limits. And again, this is going to matter on business use case. It's going to matter on cost, performance. You really kind of need to figure out these things as you're pulling it through. And then real-time app enablement. So when my application is doing something, this is key to usability, because if I've got a big chunk of latency, users are going to abandon the application, because in the age of TikTok, everybody's got the attention span of a goldfish, and they're used to applications coming back almost in immediate real time. So I need my application to be very performant. So again, query times matter. And this is something that we really want to go into, especially now we talk about AI, because not just for large language models, but for machine learning and other things where I'm doing inference, because this is now key for fraud detection. Any of the other things, kind of real-time usability, this is now going to matter in terms of, am I giving my application the right answer? Am I making the right inference quickly and easily? And am I giving my models, whether it's an LLM model or a machine learning model, am I giving it the right information quickly so it can give me its answer fast and in real time and put that together? Finally, SQL compatible. SQL is the lingua franca of every database. It needs to be in a format that I don't have to learn some proprietary query language that only works for one database type. I need to be able to run this query across multiple data sets, multiple things, and be able to come back in real time. And this is how we're defining, the real-time analytics space in terms of how we think about it. And this is the lens that we are putting together as we put together then the category of real-time analytics databases.
Yeah, if I could add on to that, like you, Whit, my background's in data warehousing. And if I were to just draw a contrast to the data warehousing category and the real-time analytic database category on a couple of these, if you take data ingest as an example, in the classic data warehousing world, it's batch ingest, right? And
Right.
certainly you can do like a micro batch, but it's still batch. And what that means is you're queuing up the data and then periodically loading it. And by the way, it gets even worse if the data is changing, right? And you've got to do upserts. There's even a longer delay around that reconciliation period. But that lends to what you were talking about earlier around that just adds the data latency, right? It's going to extend the amount of time between data creation and the insight. And what's different about this category is the leaders in it are able to just stream data in straight from Kafka without any batching, as fast as Kafka can stream it. And also, even the better tools in that can also do real-time upserts such that, there's no waiting period or back-end reconciliation around it. As the data streams in, if it's an update to a record, it immediately is reflected in the data. On the schema too, like one of the things that would break a data warehouse is someone upstream changes the data, right? So if you're ingesting data from Kafka and an engineer decides to remove a field or add 2 new fields, what is unique about this category is, again, sort of the better players in it can handle that. They can ingest it and then, on the back end, sort of figure out what you want to do with the change in the schema.
Yeah,
and I think,
Chad,
yeah,
as a good story on that. I
okay.
still have dark circles under my eyes from engineers changing schemas, getting a call at 3 a.m. because the batch load broke in the data warehouse.
Yeah.
Now we've got really dynamic things where we're looking at kind of self-documenting schemas like JSON, and I can pull those things in and I can handle that in real time. This is really kind of key because as we live in a world of DevOps, schemas change all the time. We don't always get the updates saying, hey, by the way, I'm going to be changing this hard-coded schema that you built all of your pipelines on, and how can I manage that? So being able to be flexible and dynamic with this as you're pulling it in is key to being able to be flexible and maintain those data pipeline ingestions. It's kind of one of the key points that we see in this, because the only way you can keep up with the DevOps engineers and all the shift left that's going on
Yep.
is to be able to be dynamic here. And traditional ETL, ELT data pipelines and batch loads frequently break because schema changes occur and the downstream systems don't know how to handle it, or the databases can't kind of manage it gracefully under that kind of load.
Yeah, I agree 100%. I guess just one last one to comment on is this real-time app enablement, and I'll share some use cases of what we're seeing. But a lot of the use cases in real-time analytics are customer facing. Now, to be sure, like there are going to be real-time analytic use cases that are internal. Might have like an observability use case where a DevOps team is trying to diagnose and root cause a problem. But so many are, how do I take a real-time data product and push it out to millions of customers if you're fortunate enough to have that kind of a business? And again, coming from the data warehousing world, we'd never think of allowing customers, right, to hit my Snowflake environment or my Databricks environment. But because the use cases have pushed vendors in this space to support that, several of them, right, are now able to do, queries per second that are in this 50,000, 80,000, 100,000 QPS and still maintain the kind of SLAs that an app developer will require, right? Your users don't want to, wait 2 seconds, 10 seconds, 30 seconds for an answer to come back. So, how do you do that at that scale while still maintaining that super fast query latency?
So, Chad, that's a great piece and so on. On this slide, we actually have some of those use cases. So let's start with ride sharing, right? We've all used Uber and Lyft. With that real time, you're looking at real time updates to my location, the location of the driver, the destination. You need that to be real time, and the driver's looking at real time traffic updates and routing changes based on traffic patterns. You need those in real time. Seconds count. That kind of goes right on top of emergency services, the same kind of thing. I started off, I had delusions in med school and then got into IT and never looked back. But because I've been a paramedic for a few years, right, emergency services seconds count in terms of how do I route the vehicles? Where am I going? Who is going where? Right? Every second makes the difference for somebody's life. So that's really kind of key. Fraud detection is another one that we see huge amounts in this. That needs to be real time. Is my transaction a fraud? Does it have the hallmarks of fraud? And this is where I need to be able to serve it up to those machine learning models that say fraud, not fraud, hot dog, not hot dog.
Mhm.
I need to be able to see that in real time and say, okay, I think this one's fraud. I'm going to flag it. How many keys are on it, and be able to look at my traditional fraud patterns across all of my transactions and my users. This scales, and if you're scaling it for an Amazon or a Walmart or a Target, you're really looking at millions of users per second. So I need to be able to scale it not just for one or two transactions, but millions per second. Social media is another one. Every like you get on Instagram, on Twitter, X now, uh, really you need to be able to see that in real time, or changes, or somebody's posting. You want to be able to see that as quickly, and you want to serve that up to the users quickly to be able to keep their attention and keep them focused. Cybersecurity and fraud detection kind of go hand in hand. I need to be able to see those threats in real time because again, seconds matter. If I have to go and have a long query latency, somebody's doing something in my system that they shouldn't be, and I need to be able to head that off real quickly. Gaming leaderboards are another thing. How quickly can you update those based on who's winning, who's losing, what are their stats? You need to be able to see that in real time because this keeps user engagement high because people are really looking and they're highly competitive and they're looking, hey, how quickly can I get that? Another one is personalized advertising. Every time you look on Facebook or click at an ad or browsing the web, the faster you can get those things to the end users, the more relevant those search patterns are. 5 years ago, I would go look at something on Google. 5 minutes later, I would see ads for it after I already bought the shoes or the whatever, and it was no longer relevant. So to be able to keep user engagement high, the faster the better, the more likely to buy, the more likely to recommend and pull things through. And supply chain and logistics, you wouldn't think that's a big one, but when you're looking at routing for Amazon delivery, FedEx, UPS, those things matter in real time because you're looking at not only global shipments where, yeah, those things go on in days, but when you're looking at package delivery, you need real time analytics. And then the last one's healthcare. Again, this kind of goes back to emergency services where you're looking at, hey, I need to be able to make decisions in real time. What's the patient doing? What is their blood pressure? What's their pulse rate? What are the things that I'm looking at, and can I make real-time decisions based on what's going on right now? Not, oh, look, they've got to run a tachycardia, their heart rate's 200. No, I need to be able to know that right now, be able to make decisions on it, and be able to alert staff to be able to handle those decisions in real time, not wait 5 minutes for something to propagate through my system, come back and then tell me, oh yeah, by the way, you need to go check on this person. It could be too late. So there's lots of reasons why, and lots of really good use cases for a real-time analytics data engine.
Yeah, I think those are all really great case studies. I'll tell you, one of the things I've noticed is sometimes there's confusion or people are struggling to get their arms around these use cases because sometimes it's an operational, transactional use case, and other times it's analytical. So just to like double click on something like ride sharing, an operational element that's real time, which has nothing to do with analytics, might be, I have a driver and I have a rider, and I'm just going to pair them up, right? And I'm going to, execute that transaction, and money will be exchanged. There's nothing analytical about that. The analytical part comes into if you're Uber, let's say, and what they're trying to do is calculate the price. Well, how do you calculate the price? Well, it's based on supply and demand. I need to know how many people are in the market to give rides and how many people are requesting rides within a particular window. And then the price goes up and down. We've all experienced that. That's very much an analytical problem, right? And why real time? Well, you don't want to set pricing based on an hour ago's supply and demand, right? You want to do it on like what's happening right now to really land on that optimized price that's right for the market. And each of these, again, it can get confusing around which is which, but each of these has both operational and analytical type use cases associated with them.
Yeah, absolutely. And again, a lot of those just kind of depend on what those use cases are.
Mhm.
So let's talk about the GigaOm sonar that we put together for this. At GigaOm, when we create a radar or a sonar, what we do is we take a lens and we look at a particular category. In this case, the real-time analytical database sector. And when we build that lens, what we look at is what are the table stakes. So when we say table stakes, it's just like playing poker. You've got to come in, everybody has to pony up $5, whatever the hand is. These are the things that all of the vendors do in this particular category. The next thing that we look at are what we call key features. These are where we see the differentiation of vendors and what they do and kind of some of their use cases and where they go. The next thing is we create a set of emerging features. This lets us be forward facing in the market in terms of where we see the market going, what do we see the vendors doing, and where's that coming from. And then finally, we look at business use cases. And these are things like scalability, flexibility, how many things can I throw at it, ease of use, much more of I'm putting my CTO hat on and how long can I use this thing? If it's going to change every few months, am I going to have to retrain my staff or can I use this for a long-term time window? Is it going to hit my use cases? Can I scale up, to 100 users, a million users, 100 million users? These are the kind of things that help us make those decisions. Then I also put it on a graph. I've got the innovation axis, and normally on a radar, we've got innovation and maturity. What innovation means is it's going to change over the life cycle. So if I go out and I buy something, I've got a 5-year contract. I know in this case that this market is dynamic and it's going to be changing a lot. So I may see some new features coming out. I may see some new workflows. I may be adding AI to certain things. I know things are going to be changing over the life cycle of my product. The next thing that we look at is the horizontal axis, which is feature versus platform play. At GigaOm, when we defined the category, we're looking at platforms, which are a fairly broad set of use cases, and at features are fairly narrow use cases, and I may stack up certain features. In this case, all the vendors fall over in the platform play because they hit most of the use cases inside of this market that you're going to be throwing analytical databases on. How we determine where the vendors sit, whether they're in the challenger outer ring or in the leader inner ring, is how do they score on each of those key features, emerging features, and business criteria that we're matting on. The closer they are to center, the higher they score. And as you can see from StarTree's positioning, you guys scored very, very well on this report. You're one of the leaders, and you're actually one of the closer ones to the center because you scored very well across all of our criteria that we analyze the vendors on.
Excellent. So appreciate that. And, obviously we've just talked about StarTree and the position on the sonar, and I'm with StarTree. StarTree is actually a commercializer of an open source project called Apache Pinot. And Apache Pinot is the underlying real-time analytic database. We offer a cloud service of that. But if you're unfamiliar with Apache Pinot, it's experienced tremendous growth and rapid adoption over the last few years. You can see some of the companies here that are working with Apache Pinot: Walmart, Apple, Slack, Uber, Target, Etsy, LinkedIn. And I want to walk you through a few of the real world case studies for a few of them. So let's first talk about LinkedIn. Apache Pinot actually was birthed out of LinkedIn. It was originally created there and then open sourced. And one of the use cases Whit talked about was social media metrics, right? So this is another one where, like, unless you really think deeply about it, it can seem like a simple problem. I'm just counting clicks or profile views. But in the case of LinkedIn, there's so much cardinality and dimensions around that, right? If you think about, I want to look at people who view my profile by geography, by their role, by what company they're in, and that has to be up to date. In fact, what LinkedIn found, this was like one of the key data products that really led to explosive growth of LinkedIn, because people would post something and then they wanted that, that addictive dopamine hit associated with how many people are actually now looking at my profile or liking or engaging with what I just posted. And again, I think the key thing to call out here is it's not just a simple counter by every post, but across all these different dimensions that really makes it rich and an interesting data product. And you can see the level of scale that LinkedIn's operating at. Over 70 products. In fact, I'm sure it's much higher than when this slide was originally created. Over 1 million events per second are ingested in real time, so that when you're looking at a metric in LinkedIn, it's not stale, it's up to date, and generating just enormous 650,000 QPS. Again, would break any traditional data warehouse. If we look at Stripe, the payment processing system, right? So they're also an Apache Pinot user in conjunction with Kafka, and they're looking at again millions of events that are occurring each day, and they've built both internal and external use cases, data products to support their business. On the external side, it's the merchants, right, that are using Stripe to do their payment processing. You can do things like cash flow analysis or segmenting your customers and cohort analytics. You can do billing analytics. Developers are building solutions where Stripe's, one piece of that application, and they might want to look at API calls and performance in real time. Certainly, fraud is a big deal within the payments world. So fraud alerts are running on Apache Pinot. Internally, developers at Stripe are looking at failure alerts of the underlying platform, different risks, and they're handling money, so they're also doing real-time financial reporting. The key is just going back to like why this has to be real time and not something you want to look at with stale data or yesterday's data. All these case studies are about acting before either revenue or trust or the customer experience is impacted. And then DoorDash is another good example of multiple use cases. They started to really engage with the restaurants that they provide services for, and they had all this great data on order failures or slow delivery times or underlying website issues associated with ordering, or maybe spikes in demand. And they're giving this data back to their merchants as a data product. And what they saw was a 60% improvement in the satisfaction from those merchants, because they're able to now use that data to address their operational environment before, again, the customer is impacted.
So, Chad, this is a great use case because this is kind of near and dear to my heart, because 2 of my kids did DoorDash. But what they were seeing was when they first started doing DoorDash, you would literally just, the merchants would just hand it over the food, and then they would get a notification once it was done, but the merchants really had no visibility into it. Or the drivers didn't really know whether the customer was satisfied, whether they gave them a bad review. And so it now really kind of incents both the merchants and the drivers, the restaurants and the drivers, to do better service, do better customer maintenance. And it really gives vendors a whole nother set of eyes in terms of how they're managing their business and not just tossing food over the wall and hoping that it gets there on time. It allows them to interact both with their customers and their drivers to make sure that they get a good experience. Because again, the drivers usually aren't dinged, it's the restaurants that are being dinged. Now, the drivers can get dinged based on their behavior, but that's not always the case. It's usually the restaurants and their social scores go down when they perceive that either the drivers are working for the restaurant, which isn't the case. The drivers are independent contractors that have nothing to do with it. But these kinds of things, you're right, really matter both to restaurants and to end users and to the person getting the food. How do we keep satisfaction high, and how do we make sure that these things work really well, both for the vendors and the community?
Yeah, it's a classic example of data as a product, right? It's the exhaust of fulfilling the original promise of the service, but there's so much value in that data. And particularly in the case of DoorDash, that data is way more impactful when it's delivered in real time. Because I know if I'm having order failures right now, I want to do something about it. I don't want to learn that like last month we had a spike in order failures. All right, sort of last slide here. I know, Whit, you talked a little bit about agentic AI. Obviously, it's a big buzzword out there, but I wanted to share a little bit about what we're hearing and seeing around how some of these innovators are thinking about what this new world looks like around AI and agents making these autonomous decisions and doing more complex workflows, and specifically the role of real-time analytical databases. So we just talked about DoorDash and food delivery. And right now, as we all know, that experience is you open up the app, you make some decisions on what to order, and that's the experience. But you can see a world where you might have an agent that says, hey, we're going to have a team offsite. There's 15 people. They have different dietary needs. I want you, agent, to just go plan the lunch, right? And it's doing a lot of things, some of it with a DoorDash or any food delivery service, and other things not. Like it might want to check, like, file the expense report for you as part of that agent service, or poll people on what they're interested in. But at some point, the agent needs to interact on things like, what would be the estimated delivery time if I place my order with this restaurant versus another? And this is going to, really see agents almost being like the new customer in that sense, right? So a lot of these systems were built for that high degree of concurrency to support millions of customers. Increasingly, they're going to need to support millions or tens of millions of agents to fulfill that service. In the fintech world, we talked a little bit about Stripe, but again, right now, as great as that service is on the analytical side, you have these merchant dashboards that can give you real-time insights into something like cash flow. Imagine having an agent monitoring your cash flow. And so in real time, it's seeing what's going on. And if there's a need to open up a line of credit, the agent goes out, negotiates that, resolves the cash flow problem. But it's increasingly taking the human a little bit more removed from it. But these agents, as they become more ubiquitous, are going to place even more demands on companies to supply these agents with the information they need to execute their task. More of an internal facing one around systems health. A lot of us are familiar with observability systems, and we're diagnosing issues associated with these increasingly complex distributed systems that we're building. A lot of times the action that you're taking when you root cause something is to say, provision additional cloud hardware to resolve that problem. Again, you could imagine agents continuously polling different analytical environments to maybe detect the issue before a human even would in a traditional observability platform, and then go ahead and take action and resolve it on behalf of the SREs before it turns into something even bigger. So yeah, we're very much on the early days of this, but you can see where the market will go as agents start to interact with these real-time analytical systems to perform these services and ultimately take action.
For system health, and cloud observability platforms, this is huge. And this is really a great use case because it's where the market's going right now. And this is, these are real use cases. Having been a cloud architect for a while and having run an AWS team, boy, that was tough to try to make sure that you're scaling fast enough, right? Back in the day, I used to have to go out and buy enough hardware so that I could manage all of my Black Friday stuff. I'd be plugging along at 10% all year, and then Black Friday would hit, and I'm plugging away at 90% until middle of January when things would fall off back to 10%. With the cloud, then I could scale it up and go, okay, I can go up and down. Well, you can't always be fast enough to hit the demand. But when your demand drops off, you're paying for unused hardware. Now, with these real time systems, I can scale up quickly enough to go, okay, something's going viral, something's happening and that I wasn't expecting. Maybe I ran a promotion in the middle of the year and I wasn't expecting the volume to hit. Now I can scale up before my SRE team, or if something happens in the middle of the night where I don't have an SRE team wide awake and who's managing the systems. Now, real-time analytic systems allow me to do that, and these use cases are absolutely brilliant because they're saving a lot of time and money, and they're help company do more with less. So these are great use cases all the way across the board, and StarTree is powering some really great innovation along the way.
Great. All right, well, that brings us to the Q&A section. So let me hop over and see if we've got any questions that have come in. All right, here's one. This is a good one for you, Whit. Many companies assume their data warehouse is fast enough. What signals tell an organization that it's time to consider a real-time analytic database?
So that's a great question. So traditionally, data warehouses were yesterday or batch or micro batch as data is coming in. But does it handle your SLAs, your SLOs for whatever your use case is? And so that's really kind of the first thing that you're looking at. Is yesterday's data good enough? If not, or every minute or every whatever, but you're really looking at, is it fast enough to be able to power my application? And is it fast enough that I'm managing kind of the expectations of my users? And what are my business criteria for that application? So most of the time the answer is yeah, the data warehouse is good enough. But when I'm handling real-time user applications like all those use cases that we talked about, no, it's not. And you're now going to have to look at purpose-built analytics that are going to solve those business use cases and really kind of help that. So you're looking for SLA, SLO, and you're looking at latency. How quickly do I need to get back to the user?
Yeah, I think that's spot on. I'll tell you, like we also see a lot of customers coming to us where, again, they've got their traditional data warehouse and they keep getting pushed as a team, right? To like shrink the data latency, shrink the query latency. And they're doing that. And then it's not so much that they're like, I can't squeeze any more of the data latency or query. It's more they like wake up one day and they're like, we're just getting crushed in costs. And is there something that we can do to radically bring that down? In fact, a lot of those case studies I shared with you, not only were they able to deliver it, but it was like, and the cost went down 60% as well. So I think what we've seen is a lot of times that trigger is just the costs are getting out of control as teams are getting pushed to just accelerate the velocity of the insight.
Right. And that's probably another great signal. Are your costs going up faster than your profits? And
Yeah.
once you hit that, then you need to start looking at, okay, I need a better way. And that's quite often an early signal for any CTO, CIO as they're kind of looking at their projected costs. As their users scale up, you're scaling that hardware up and distributing it out and pushing it out. And pretty soon you realize I've got more hardware than I know what to do with. And I'm paying for somebody's new yacht, and I don't think this is a good idea.
All right. Another question. This is a good one for you as well. Why shouldn't we just build our own real-time pipelines with tools like Kafka, Flink, and Spark instead of adopting a dedicated real-time analytic database? It's a great question because those aren't databases and they're very much tools associated with real-time. How should we think about that?
So Kafka is cool, but it's just a streaming pipeline. It's basically just a messaging queue, and it is a lousy analytics database. You may be able to ask it some questions along the way, but you've got to catch all of those message queues, and you can't really do analytics on it.
I
We've
think that's
discovered,
right. It's kind of a narrow window, right? Yeah.
yeah, it's a narrow window, and you're really only looking at, hey, here's what's going on now. When you're looking at an analytics database, you can give it more data, so you can say, give me stuff that's going on kind of in the past. Same way with Flink, same way with some of these other tools. You just don't have the depth and breadth to be able to give it good answers. You can only say, hey, here's what's going on now. Same way with Spark. Spark's great for, hey, tell me what's going on, but you're only getting inside the window that you're analyzing. You're not getting within the last couple of days, the last couple of months. You really can't get good answers. And so when you're looking at analytics, you're looking at history and other things that you can be able to serve up the models, and they can go, okay, these things look like fraud, these things look good. Here is some history. Here's some other things that you need. So they're really good, but they're not great analytics databases.
I think that's spot on. So it looks like we're at time now. So I want to thank everyone for joining us today. If you haven't had a chance to check out the report that Whit and GigaOm helped put together, we'll make sure everyone gets an email copy of that. Again, thanks for joining us.
Awesome. Thank you, Chad. This has been a fun conversation.
Likewise. Bye.